All right, this is session 3.3. This is Foundations of Math 20, and we're taking a look at the cosine law. So here's some homework questions that you might need help with. So number one, let's first of all look at number one. Suppose that you're given each set of data for triangle ABC. Can you use the cosine law to determine C? Okay, can you use the cosine law? It might be easiest to think about, hey, can we use the sine law? Because you know in the sine law you have to have an angle and its opposite side that are known. That's for the sine law. Now what we learned today, or just recently with the cosine law, is that there are two different cases where the cosine law has to be used. So the one case was SAS, remember that. So that is if you're given a side, an angle, and then the other side, so that they are all three in a row like this, side, angle, side. If you're given these, then you can use cosine law, all right? And if you're given all three sides, that should be an S. So if you're given all three sides with no angles, but all three sides, that counts, and then you can use cosine law, all right? So we have to check with each one of these. So A says I've got an A length, I've got an angle A, and I've got an angle C. So that is, I'm on this diagram over here, I'm going to circle the ones that I'm given. A, and angle C. Okay, now this one looks prime for the sine law because I've got these two. But do I have enough? Do I have side, angle, side, or side, side, side for the cosine law? And it turns out that I do not. I have more like an angle, side. That's what I have here, angle, side. And so that one doesn't count. That's a good sine law one. So A is no to cosine law because it is angle, side. And that's all I would need for your explanation. Okay. So B, if we look at B, then again over here on the diagram, I'll highlight what we're given and we'll see if it qualifies for the cosine law. So let's see, I'm given this one, side A. I'm given side B, and I'm given angle C. See, this is side, angle, side. So that does check out. So B is, yes, you can use the cosine law, and that's because it's a side, angle, side triangle. So the information that's given is the side, two sides, and the contained angle. That's the way you say that. Two sides and its contained angle. If the angle that was given was over here, that doesn't count. This is side, angle is what that is. So side, angle that doesn't count. That's not one of these. All right, so just as an example. All right, so that is number one. Number two, now I have number two all worked out here for you, so I'll just highlight some of the important points. For example, if we want to find out a missing side, then what's important is that this missing side goes on the left side of the equation all by itself and it's squared. Okay, the one you want to find goes over there. And of course this is side, angle, side, so this is going to work, right, for the cosine law. So we've already have that established. Now what I do here is I have to make this part look like the Pythagorean theorem, right? And so how do I do that? Well, equals this side squared plus this side squared. Okay, now I always do a minus and a 2 times, and the values that you put in there are the same values that you used on the same side, so 15 times 18. And then finally the 46 degrees is where it goes here in the end, the cos of 46, so that if you are using this all by itself on the one side, then you know that cos of 46 has to go on the opposite, very opposite side. Those always have to like kind of balance off. Okay, so then what I did here was I evaluated everything. I did this, and I subtracted, and I multiplied all this together to get 173.88. Please make sure you can get this on your calculator. And then to solve for x, I have to make sure I remember to square root both sides, and this should be your answer for 2. Now, the back of the book, the solution manual might just show 13 centimeters. It might round it to the nearest centimeter. That's fine. I always encourage you to do 1/10 for the side lengths and for the angles too, so that we're a little bit more precise. But that's number 2. Now, number 3 is a little bit more on the tricky side because we have to solve for an angle. So let me walk you through that. Okay, solving for an angle. Now this is side, side, side. So that is good. SAS is good for cosine law. And again, what you want to do, the angle that you're trying to solve for, in this case, the question asks to solve for P, well then 5.9 has to be on the opposite end of the equation. So here's cos P over here. I don't know what P is, so I leave it just as unknown angle P, okay? But on the opposite end has to be the 5.9. That's how I know, see? These are always opposite each other, opposite end. And now I fill in everything else, okay? I know this has got to look like Pythagoras right here. So if I've got 5.9 here, guess what? Equals the other two sides squared and added. Okay, always the same there. Then I'll do a minus and a 2 times the sides that I squared on the same side there, these two sides, cos P. So now here's where it gets a little tricky. So you have options here. I would hesitate to do all of this in one big calculation on your calculator just because you might miss a bracket or mess up and it could be a big mistake. But the safest thing to do would be to evaluate each one of these separately and write them down. Okay, it'll take you an extra literally 20 seconds to do that. And then you'll find this product here, that multiply all those together and put that there as well. Now what you see is that it's easy to take this side length over there to the other side and this side length over there to the other side. And so you have 34.81 minus 5.29 minus 38.44 to get this value. And then I'm left with a negative 28.52 cos P, and I divide by negative 28.52. Excuse me, both sides. And that leaves me with cos P all by itself, and this division gives me this number. Now, a couple things that I pointed out to my class here today, that two important things. In this, when you're solving for angles, if you get cos of an angle and it equals a number that's larger than 1, then you've done something wrong, okay? So this only works, okay? You can only find an angle P when this number is less than 1, between 0 and 1. So it has to be like 0.3. If it's 1.3 or 5.3 or 10.3, you've done something wrong and you won't be able to find this angle. Your calculator will say something's wrong. So this has to be a number between 0 and 1. Okay, so the second thing is what you do to solve for P. Just remember, you do cos to the negative 1, okay, of P. I'll try and show you that on my calculator here. So that is the, oh, I have it up here on my calculator. Look at that. Okay, so actually what I'll do is I'll take a snapshot of this. Come on. Sweet, it's the last thing I did on this calculator. Love it. Okay, now I'll plop that right here. Beauty. Okay, so let's examine this now. So you see how I did the 5.9 squared, which is the 34.81, and I subtracted 5.9, subtract 38.44 to get this 8.92. See, negative 8.92 right here. Then I divided both sides by 28.52, and I got this number, 0.31276. Okay, that one. Now it's cos to the negative 1. So on the calculator, that is the second function cos right here. See, cos to the negative 1. I know you know this. I know you know this. I'm just going over this again just to make sure, okay? Just in case somebody doesn't know this. You have to use that cos to the negative 1. This one right here, second function. Okay, don't try and divide by cos. If you try and divide by cos, it's not going to work. Make sure your calculator is in degrees because you want angles in degrees. Not like an R on your calculator or radians or gradians or anything like that. It has to be degrees. And so you should get 71.8 if you're doing this correctly. So yeah, that's 3. And that's how you solve for an angle. Okay, have fun. See you later.